Hello students, in lesson number 8, motion, we have completed the numericals based on the speed and velocity calculations. Now further, rate of change of velocity. See, whenever for the uniform motion, we understand the uniform motion, right? When the distance traveled by the object is equal in equal interval of time. That means the object travels at the constant speed, right? So in other words, we can say that uniform motion is a constant speed motion where speed don't change, right? So now, for the non-uniform motion, when the speed changes, the question arises that how fast this speed changes. Let us take one example. When you are going on your vehicle, you see your friend at some distance, okay, and you want to stop your vehicle. So you are going with some speed or at some velocity, and then you want to stop your vehicle at your friend, right? Friend is standing at some distance. So you are trying, you want to change your velocity, you want to change your speed. So to change the speed, you are applying brakes to the vehicle. And as you are applying the brakes, the vehicle slowly slow down and comes to rest. That means the vehicle stops. Okay. So your velocity becomes zero at your front. And you are slowly slowing down your vehicle. But in another case, when you are going in the vehicle and suddenly at some turn another vehicle comes and suddenly you have to stop your vehicle. So in that case, you are applying the brakes and your vehicle stops, but for the time interval is much more, right? The time interval is very less for the vehicle to be stopped. So in both the case, the vehicle stops, the velocity becomes zero, but here the time interval is different. It means that in the first case, when you are seeing the friend, your change of velocity is very slow. And in another case, you are changing the velocity very fastly. Okay. So that defines the another term, rate of change of velocity. Rate means at how fastly something changes. Right? So here the velocity is changing. So for the rate of change of velocity, another term is defined that is called acceleration. So when the acceleration produced, wherever there is a change in velocity, we can say that acceleration is produced. If the velocity is constant, there is no acceleration. The acceleration is zero for constant velocity motion. That means if the speed is constant, there is no change in speed. And if there is no change in speed and velocity, then acceleration is zero. But wherever the speed changes for a non-uniform motion, acceleration is produced. And the definition for acceleration is nothing but the rate of change of velocity. And so the definition can be as it is. Acceleration is equal to change in velocity per time taken. Okay. So change in velocity per unit time is the acceleration. So the formula can be as acceleration is equal to change in velocity upon time taken. Okay. So velocity changes. Let us say the initial velocity is small u. Okay. In this physics part, the symbols is very particular to a particular quantity. So, or wherever there is a small u, we understand that small u is the initial velocity, and after some time the velocity changes. So that becomes the final velocity, that is v. Okay, small v. Small u represents the initial velocity. Small v represents the final velocity. So acceleration has symbol small a. Okay, it has small a is equal to a is equal to change in velocity. That means difference. Change means difference. So final velocity minus initial velocity will give you the change in velocity, and for that change, how much time is taken, that is t. Okay. So symbolically, the formula can be written as a is equal to v minus u upon t. So this is the formula for acceleration. Wherever We want to find the acceleration. We need initial velocity, final velocity, and the time interval to change the velocity. That quantities we need so that we can find the acceleration of that object. Okay, so to measure the acceleration, what unit is used? Unit, we mean that, see, mass have the unit kilogram, distance has unit meter, kilometer, etc. Time has second. So this acceleration also has some unit. Okay, so the unit can be obtained from the formulas. See, acceleration is equal to, numerator has the velocity term and denominator has time term. So the unit has the same dimension. So numerator has the velocity term. So velocity unit is meter per second and denominator has time term. So the time will be second. So meter per second upon time unit is second. So this denominator of numerator goes to denominator. So second into second, second square. So the unit for acceleration is meter per second square. Okay. So this is the unit for acceleration. Acceleration is measured in meter per second square unit. So this we need to remember. Okay. So here the acceleration is defined wherever there is a non-uniform motion. Now there are two cases for this formula. First one, if v is greater than u, v means final velocity greater than initial velocity. It means that initially the velocity is less and then after the velocity increases and the final velocity becomes is more than the initial velocity. It means that when you are speeding up, when the vehicle is speeding up, v is greater than u. Then the difference, that means bigger number minus smaller number, will be greater than 0, that means positive. So v minus u term will be greater than 0. And here, if the v minus u term is greater than 0, that means positive. And denominator time is always positive. Then positive upon positive, the answer will be positive. So a is greater than 0. That means that, which implies that a is positive. It means acceleration is positive when v is greater than u. When final velocity greater than the initial velocity. So whenever the object velocity increases, acceleration becomes positive. So this type of motion is represented as accelerated motion. Okay, and so for the accelerated motion, acceleration is positive, which represents that the object is speeding up. The velocity of the object is increasing. For the second case, if v is less than u, that means that v final velocity is less than the initial velocity. That means the object slow down and finally the velocity is smaller than the initial one. Then this difference v minus u is less than. Whenever we need this difference in the formula. So v minus u, that means smaller minus bigger value. This difference will be negative. That means less than 0. So if this term is negative, t is positive. So negative upon positive, the answer will be negative. So a is less than 0, which implies that a is negative. And this kind of motion, when the object slows down, okay, the velocity decreases finally. This kind of motion is known as retarded motion. Okay. And for the retarded motion, a acceleration is always negative. So the value of acceleration, positive or negative, represents the whether the object is speeding up or slowing down. Right? So this is the whole idea about the acceleration. So how to calculate the numericals based on this acceleration for formula? Let us do it. Example 8.4. The question is like this: starting from a stationary position. Stationary position means at rest. Okay, so object starts from the rest. So its initial point is rest position. So initial velocity is 0. Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Okay, so it starts from the rest position. So its initial velocity is 0. Now it starts its motion. So we are We are observing this motion from starting point to up to the end point. Right? So here, at starting, the initial velocity is 0. So, and after the vehicle, the Rahul pedals his bicycle and it attained the velocity 6 meter per second. So, its final velocity is 6 meter per second. And during this, to change this velocity from 0 to 6, it takes 30-second time. Then he applies brakes such that the velocity comes down to 4 meter per second in 5 seconds. So after attaining to 6 seconds, there is another case where he applies brakes now at 6 meter per second. After that, when it applies the brake, the bicycle slow down and the velocity decreases to 4 meter per second. And to change 6 to 4, it takes 5 seconds. So calculate the acceleration in both the cases. There are two cases. First case is increasing the velocity and then after decreasing the velocity. So for the first case, let us find the acceleration. For the first case, it starts from initial rest position, stationary position. So initial velocity is 0. That means u is 0. And it attained the velocity 6 meter per second. So final velocity is 6 meter per second. And to change this velocity, it takes 30-second time. So acceleration formula we can find it. Acceleration A is equal to V minus U upon T. Put the values. V is 6 minus U is 0 upon 30. 6 minus 0, 6 upon 30. 6 5s are 30, 1 upon 5. And the decimal expression for 1 upon 5, when we divide 1 by 5, the answer will become 0.2. And unit for acceleration is meter per second square. So acceleration is equal to 0.2 meter per second square. And here we are getting the positive value. It means that it is the accelerated motion, means the velocity increasing. So here it is increasing 0 to 6, increasing velocity. So this is how we can find the acceleration. Units are very much necessary in answer. If you forget to write the units, the marks will be cut. For the second case, okay, so bicycle is now at 6 meter per second and it travels 6 meter per travels at constant 6 meter per second velocity. After some time, Rahul applies the brakes, right? So from 6, so now it becomes the initial velocity, u is equal to 6 meter per second. From that point, it applies the brake and final velocity will become 4 meter per second. So for the second case, the data is like this. Initial velocity 6 meter per second. For that decreasing velocity case, v is equal to 4 meter per second, and to change this velocity 6 to 4, it takes time 5 seconds. So t is equal to 5 seconds. Again we can put the formula. Acceleration A is equal to v minus u upon t. V is 4 minus u is 6 upon time is 5. 4 minus 6, smaller number minus bigger number. We get the negative answer, that is minus 2 upon 5. And when we divide 2 with 5, we are getting 0.4. So that is negative 0.4 and the unit for acceleration is meter per second square. So acceleration for the second case, we are getting A is equal to minus 0.4 meter per second square. So it proves that the negative value of acceleration represents that the vehicle slow down. Okay, and so for the slowing down, when the brakes are applied, we are getting the negative acceleration. So this is how simply by putting the formula and putting the values, we can calculate the acceleration. Further, in page number 103, in text question number 2, there is a numerical. So let us do that. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of a bus. Okay, one bus is there which applies the brakes and decreases its speed from 80 km per hour to 60 km per hour. We know that bus travel, the measurements of the speed of the bus is in kilometer per hour. So that is also unit for speed. So its speed decreases from 80 km per hour to 60 km per hour in 5 seconds. So time interval is also given. Find the acceleration. So from 80 to 60, that means initial velocity. So the data given is initial velocity u is equal to 80 km per hour and final velocity v is equal to 60 km per hour, right? So during this change, we need to find the acceleration for that change, right? But here, we know that first of all, we need to change the units to standard unit because time isn't given second and here the time is in hour. That can't be done. Okay, that's not working because always the quantities needs to have the same unit. If the time is in second, everywhere the time is should be in second. Okay, so we need to convert this kilometer per hour to its standard unit, that is meter per second, and we have learned that kilometer per hour can be converted into meter per second by multiplying with 5 upon 18. Wherever you multiply it with 5 upon 18, you can change from kilometer per hour to meter per second. So here we multiply 80 with 5 upon 18. So we can cut the numbers as 9 twos are 80, 40 twos are 9 twos are 80, 40 twos are 80 meter per second. And again 45s are 200 upon 9 meter per second. So this we are keeping it as it is. And final velocity is 60 kilometer per hour. Sorry, it is hour here, which can be converted to meter per second by multiplying with 5 upon 18. 60 into 5 by 18. We can cut it like 9 twos are 18 and 30 twos are 60. So we are at 35 are 150 upon 9 meter per second. So we have now standard units. The first thing in numerical is to convert the units to standard unit. Okay, we need to check the units. If the units are in standard unit, then and then only we can move further. We can calculate and the answer can be correct. Otherwise, the answer will be wrong. Okay, so we are having the units in meter per second here, and time is in second. That is the standard unit. Now we can find the acceleration. We have the formula acceleration a is equal to v minus u upon t. Put the values. V is 150 upon 9, so we are putting it, minus u is 200 upon 9, that is 200 upon 9, and the whole divided with t, that is 5 seconds. See, it has the same denominator, so we don't need to take the LCM. So 150 minus 200 upon 9, and that goes to denominator of the numerator goes to denominator, right? So this 9 goes in denominator, multiplied with 5, already it has 5, is equal to 150 minus 200, smaller to bigger number. So we are getting the negative value minus 50 upon 9 into 5, right? So this 5 can be cut with 50, 5 tens are 50. So we are at the result minus 10 upon 9. If we divide 10 with 9, we are getting minus 1.1111. That continues, but we are always writing the number after point 2 digits. Okay, so minus 1.11 and the unit is meter per second square. So the acceleration is 1.11 meter per second square minus 1.11, and the negative value represents that the speed is decreasing. So yes, burst speed is decreased. Okay, so that always gives the negative acceleration. So it is a retarded motion with negative acceleration. Further, third one, a train starting from a railway station. Okay, so train is standing at the railway station. Now it starts the motion. See, the details are always hidden in the words in the question, right? So, the starting from a railway station and moving with a uniform acceleration attains a speed of 40 km per hour in 10 minutes. So, only one speed is given, 40 km per hour. So, that will be final or initial? It will be the final. It attains this speed in 10 minutes, right? And where we are getting the initial velocity? Here, from this word. See, these are the keywords: at rest, starting from the rest position, starting position. Okay, so this keywords represents that the initial velocity is 0. So a train starting from a railway station, that means the initial velocity is 0. So we can put the data, u is equal to 0. Final velocity, it attains the velocity 40 km per hour, and it is moving with a uniform acceleration. Acceleration means change in velocity, right? And uniform acceleration means the change is constant. Okay, every time the change is constant. That represents the uniform acceleration. So u is 0, v is equal to 40 kilometer per hour. So we need to convert into meter per second, standard unit, with 5 by 18. 40 into 5 by 18. So we cut it with 9 twos are 18, 20 twos are 40. 25 are 100 upon 9 meter per second. That is the conversion to standard units. This is must. And time is given in 10 minutes. So here time is also not in a standard unit. So we need to convert into standard unit. So how to convert minute to second? By multiplying with 60. In every minute there are 60 seconds. So 10 multiplied with 60 will give 600 seconds. So now we have the units in standard form. So now we can calculate acceleration of the bus, of the train. Acceleration A is equal to V minus U upon T. Put the values 100 upon 9, that is V, minus initial velocity U is 0. So we put 0 here, divided by T, 600. So 100 upon 9 minus 0, that will be 100 upon 9. This 9 of the numerator goes to denominator, multiplied with 600. So 100 upon 9 into 600. 20 can be cut. So we are at 1 upon 9 6 are 54. So we can divide 1 with 54. How to divide it? The division is here. 1 divided by 54, we can't divide it. So we are putting a decimal point, we are getting 10. That is a 10. Still we can't do this. So we want another 0. So for that another 0, we are putting after point, there is another 0, 0.0. And decimal point will give 10. And for another 0, we have to put 10 here. So 0.0. Now it is 100. So we can divide it. 54 ones are 54. By division we are getting 46. 10 we can get 460. 54 8s are 432. We are remaining with 28. 0. 54 5s are 270. 10. 10 100. So this will continue. So the answer is 0.018 meter per second. Is it positive? Yes. Positive acceleration represents that the train speed increases. So yes, it is increasing from rest position to attain the some speed like 40 kilometer per hour. That's why it is a positive acceleration. So this is the simple calculation based on one acceleration formula. So write down in your notebook, and still if you have any doubt, you can ask me. Thank you.